Let's have a look at the computer program. Once again, I have a function f of x. At present, it's set to f of x equals x squared. Again, I have a slider to change the value of a, which in this case is my scale factor. And I have a new function, g of x equals a times f of x. Now, by changing the scale factor, we should see exactly what we saw on the sketch. Because it's sometimes hard to see exactly what is happening with a dilation, I have these buttons here that allow me to hide the graphs and just show a few points on the graph.
Okay, so if we change a from 1 to 2, then all those points should move further away from the x-axis.
I think you're right, but let's check.
See, I'm not just a pretty face. What happens when we move the marker to a position less than 1 but greater than 0?
Well, what would you expect to happen?
Well, I guess the points of the transformed functions would end up closer to the x-axis than the original points of the function.
Why do you ask when you know the answer? Let's confirm this.
I love it. One last question. Please turn the graph back on so we can see what happens as the values of a change.
There you have it.
That gave the impression that the arms of the parabola were moving closer together. But that is not really what happened, is it?
That is exactly why I wanted us to look at all the individual points first. The point making up the graph all moved further away from the x-axis as they were stretched up. Now this gave the impression that the arms moved together. To understand this vertical stretch transformation, we need to focus our attention on the points on the graph.